Alright, we're gonna work on some digital design problems. I'm at a cafe, it's loud. I've been messing around with the sound. Should be good. Dealing with some feedback, which we're actually gonna talk about. It's a problem. Alright, let's start. Okay. Right here, what we got is here's your circuit. Here's the problem. Right now, I'm not going to go into everything in detail. This will take about 45 minutes. So, the more I talk, less I think. I need to get better at speaking. Speaking out loud while I do problems if I'm doing this channel. Okay, so first I'm going to start with taking these signals and putting them into a Boolean equation. So this is your Boolean equation. And from there, we're going to take the Boolean equation, we're going to code the digital design and hardware description language called Verilog that I'll put here. And that we're going to put in this little tool that you could use to simulate like a flight simulator for circuits. And we'll do that here. So 3 parts. First, derive the Boolean equation from the signals. All right, so if gate X is your intermediate signal, A is your primary signal. I'll list those later. A and Q1 go through an AND gate. Y is E or gate. This is an OR gate. That's how you write OR. Z is another intermediate signal. X OR goes through OR gate. Then Z splits into 2 paths. W, E, and Q2. That's your state value. Q is your output. This signal that it's sequential, which means that it has a flip flop, which means that it stores your state. Or that's how you write. D1 is your data, your first data from your first flip flop. B is another primary signal. This is your second flip flop. It's positive edge triggered. Active high. We'll draw that. Yes. So now we're gonna circuit. Now we're gonna do the input and output wires. The primary ones that I was mentioning before. Primary ones are A and B. told you it's sequential. So we need a clock. Has a reset. So reset. And has two states, Q1 and Q2. Okay, now I need your intermediate signals. X, that's all these on the left. Y, Z, W, Z, B. See with your intermediate signals. Now you need your. I already got that. Combinational signals here. Which is your okay. Positive edge clock. So clock looks like this. This is how the clock looks. Positive, negative, positive, negative. Now it could be a 10-second clock where this is 5 seconds. That. So from the time that it goes positive, to the time that it goes negative, it's 10 seconds. One full cycle is, let's go positive. Let's go from here. That's one full cycle. From 0 to 1, this is 1 high. That's high. 1. And this is low. So. And that's how the clock goes. Round and round. Now we gotta do the reset. If reset, this means if reset is 1. Set first flip-flop state to 0. Same with wow. 2. Else, so it sets the reset. If the reset is 1, set the clock to 0. I'll talk about that in a second. Else, Q1, B1, state of output state, set the output state to the current value, the data. And see that bad guy where. So this means, what that means is we're going to set the state to 0 on the reset. So when the reset is high, because it's active high, this is high, we're going to set it to 0. Reset the reset to 0. That wipes out any of the values. It's like starting from a clean slate, literally. Now, from here, with this, you're going to set each flip-flop to its current, whatever its current data is. So it's like, it'll look like this. Data coming in. This output will get set to this here, that data input. Roger. That's your circuit. See the clock, see the reset, see your inputs, see your mux. This is what a synthesis is, hardware synthesis, taking HDL, hardware description language like Verilog, and synthesizing it to actual circuits. Okay, now let's take this and write a test bench. It's a little tricky. This. I think I gotta. Now. You have to name it. Module has to be. Now we gotta do the. Okay, we have to do the inputs and outputs, same as like here, but I have to write them differently. So the input, the wires are the primary input, those switch to registers. So it gets flip-flop because one's, it's going outside, excuse me. It's going outside think of it like it's being driven. So you're plugging it into, you're taking the circuit and you're plugging it into the outside world, hypothetically. So input wire A, B, clock, reset, all become register. A, B, clock, reset. Now, vice versa for wire. So now, this, or excuse me, for register, that now becomes wire. So it's wire Q1 and Q2. Now I need to do all the steps. Need to instantiate it. You need to generate a clock. Then you need to initialize it. Initialize the values, the output. Initialize the you have to initialize the values. Then you have to do the combinational. I got to do this display too, but I'm not going to code that. I'm just going to use the clock console. So instantiated circuit UU2. Now we take all these and we're going to instantiate them. And by that I mean it would be like taking this. It'd be like taking these A, plugging it in, plugging it in, B to plugging it in, and to an outside to an outside or to an external device, the driver, which like I said is like a say commas. I doubt this guy is swimmingly. We're gonna give it a whirl. Now, like I said with the clock, I'm gonna go 10 seconds, so I'll have the 1 clock cycle. I'm gonna toggle it. That's how you toggle. Meaning up and down, up and down. Then the console will do that later. Initialize the value. But now don't initialize the output, just the inputs. And we're gonna start with the reset, fired up, pressed, so that everything's 0. Then we'll wait. Allow for 2 clock cycles. Deassert the reset. Now these gotta go like a couple of one, 2, 3, 4, 5, 6, 7. All right. How do I do this combination settings? Oh, okay. I need to do okay, I have 2 inputs. 2 inputs, so 2 raised to the power 2 to the second power. 4 combinations. So it's like A. I don't need this. I only need 1, 2, 3, 4. A. Now we're just going to count to binary and 4. So it's only the combinations. We're only using the how many combinations of zeros and ones you can with A and B, which is only 4. Easy peasy. So 0 with binary 1. Binary 2 is 10. Finished. I don't think it's gonna work. We're gonna see what. I think I have to do them always make it here. Let's see what I get. Implicit definition of wire. C, 9, 4. Syntax error 68. I think it's. I don't know if I have to do, or I have to put it on. 75 syntax error. Finish another valid elaboration task. Finish N. Somewhere. Invalid module item. Is it just finish? I thought that's how you do it. I also need to display. Write me the display for this to display the results on the console. Why is this an invalid module item? Ah. Should be inside the block. Okay, now here's the display. All this is going to do is just show the time, the clock, to reset the value, all the values that I get in the console. Okay. No, I don't like that. Hold on. Write the display so that the variable value like clock reset is in front of the binary number. That way I don't have to look up at the top of the rows to see what the value is. Here we go. You could see the reset is active. You don't know any of the outputs, any of the Q2s are all undefined with X. Everything is undefined, that's correct. And I set at 2 clock cycles later, the reset goes low, which means that 20 seconds, then you should start seeing, you shouldn't see anything undefined. So there's everything should be 0 here. Huh. V. Oh yeah, V, okay. V is 1. Right, the reset never, oh I see. The reset never got deactivated. Why didn't the reset ever deactivate? I can figure out why the reset never deactivated. That I don't know. Why didn't my reset deactivate? All the resets are 1 and never went back to 0. Should have. I set it to 0 there. Let's see what we got here. Because I use an always block, not an initial block. Ah, derp. Alright. Now you see the reset go to 0. And then everything. The reset. I'm a bit confused still, that's right. Why is this V value 1 if the reset is active? Everything should be 0. So why is the v value 1 if the reset is high? All the values should be 0. Because reset only forces the flip-flop outputs Q1 and Q2 to 0. It does not automatically force every combinational signal to 0. It only forces the output to 0. So it looks like that's it. That's correct. Is this correct? I think I'm right. I think I'm right. Yes. Yep. We're good. This is.